All right, as you can see here, we're going to be talking about similar figures in this lesson. So let's get to the definition of similar polygons, which is related to similar figures. So there's an informal definition, and it really doesn't even have to be polygons, but it says two figures are similar if they have the same shape but not necessarily the same size. But more formally, and this is for polygons, two polygons are similar if and there's two parts to this, their corresponding angles are congruent and the lengths of corresponding sides are proportional. So in order for polygons to be similar, it has to fit those two criteria. Or if you have similar polygons, it will fit those two criteria, or those criteria will be true. Here is the symbol for similar, kind of like congruent, but doesn't have the equal sign underneath. So this would be talking about similar figures, not polygons. So which ones are similar? Well, looking at one, those are the same figure, but they're different sizes. So they're the same shape, but not the same size, so they are similar. Number two, here at the two coffee cups, well, in our everyday life, you would say, oh, well, they're similar pictures, but they are not similar figures according to geometry. Same thing with number three, it's both cake, but not similar figures. And then number four, they are similar. So this next one, it says the following quadrilaterals are similar, show that the lengths of corresponding sides are proportional. So up here, it shows quadrilateral HIJK is similar to WXYZ. Now order is important. This means angle H corresponds with W, I with X, J with Y, and K with Z. It also means that these segments are corresponding. So segment HI goes with segment WX, and segment IJ goes with segment XY, and you could continue on in that manner. So what we're going to do is we're going to look at the ratios of corresponding sides. So let's take a look. So HI compared to WX, and we put that in a ratio 6/3. That reduces to 2/1, which is 2. Now looking at the next one, IJ. So you see IJ is 9 compared to XY is 4.5. That also reduces to 2, and the pattern keeps going. JK over YZ, which is 6, reduces to 2. And the last one, this longest segment, KH15 over ZW 7.5 is 2. So we show that the corresponding sides are proportional. Proportional means that the fractions are all equal to each other, and all those fractions, these fractions, all equal 2, so they're proportional. Let's take look at one more thing. Let's look at the ratio of the perimeters of the two figures there. So to find the perimeter of quadrilateral HIJK, you just add up all the sides. And same thing with the other quadrilateral. So we have 6 plus 9 plus 12 plus 15. That's for this perimeter of HIJK. And then for quadrilateral WXYZ, you have that in the denominator. Add those things together. In the numerator, you get 42 over 21. And would you look at that? It reduces to 2. And so we notice here, this shows or demonstrates another theorem that if two polygons are similar, then the ratio of the perimeters is equal to the ratio of the corresponding sides. So the ratio of the perimeter, 2, will equal the ratio of the corresponding sides. Good to know. Next thing, you're given the length and width of 3 rectangles. Which 2 rectangles are similar? Well, as you look at this, 4 to 5, 6 to 7, and 8 centimeters to 10 centimeters. If you think through that, you have 4 to 8. I know this is in centimeters, but you have 1/2 inches over centimeters. And if you do 5 inches over 10 centimeters, you have 1 inch over 2 centimeters, it reduces to the same thing. So A and C are the ones that are similar. And we know that going by definition, both are rectangles. So all the angles are congruent. So remember, definition of similar, all corresponding angles are congruent and sides are proportional. And then we see that the sides are proportional also. So sketch, if possible, two similar kites that are not congruent. Well, that shouldn't be too bad because you can have big kites and little kites. So here we go. Just again for the definition, angles are congruent. So corresponding angles are congruent. And then if we looked at the corresponding sides, they would be proportional. Next one, sketch, if possible, two equilateral triangles that are not similar. Well, if you drew two equilateral triangles, all the angles would have 60. So all the angles are congruent, and then really all the sides will also be proportional. So this is not possible. All equilateral triangles are similar. And then lastly, a square and a rectangle are sometimes, always, or never similar. Remember, be careful about this because a square is a type of rectangle, always, and a rectangle could be a square. So this is going to be sometimes. So if this rectangle happens to be a square, then they will be similar. So the answer is sometimes. And that is the lesson on similar figures, or more specifically, similar polygons. And you must know that corresponding angles are congruent and corresponding sides are proportional.